Hello friends, today we'll start with equivalent lateral design of an RC frame. We'll take up next problem. Plan and elevation of a 4-story RCC building is given. Live load 3 kilonewtons per meter square. Column size is 450 by 450. Beam size is 250 by 400 mm. Thickness of slab 120 mm. Importance factor 1.0. Ordinary moment resting frame structure OMRF structure. Determine seismic lateral loads and story shear force distribution. That is, we have to calculate base shear and its distribution. This is the plan. This red indicates the column. These are the beams. This is the plan of the structure. 7.5 meters in each direction is the dimension. Now this is the elevation. 1, 2, 3 and 4. 4 stories. Height of each story is given as 3 meters. So this is the spacing between the two columns. These are the two columns. This is the elevation. Now here seismic loads W1, W2, W3 and W4. You need to determine these. These are not given. In this problem you need to calculate seismic weight W. So step 1. Calculation of seismic weights. Assume unit weight of concrete 25 kilonewtons per meter cube and masonry 20 kilonewtons per meter cube, because also here thickness of wall is given. Sorry, here thickness of slab is 150 and thickness of wall is given as 120 mm. Thickness of wall, thickness of slab is 150. So first let us start with slab. First calculate total L and B. Length 7.5 plus 7.5 plus 7.5. So length is equal to 22.5. B 7.5, 7.5, 7.5. 22.5 meters. Thickness of slab. Thickness of the slab is given as 150 mm. 0.15 meters. Next, dead load due to slab. L into B into D into unit weight. So 22.5 into 22.5 into 0.15 into 25. You get the value 1898.4 kilonewtons. Second, beams. First find out the total length of the beam. So here the beams are running in x direction. 1, 2, 3, 4, 4 beams. Each is 22.5, 22.5, 22.5, 22.5. Similarly in y direction 1, 2, 3, 4. So total length of beams is equal to 22.5 into 4 in each direction. So this into 2 in other direction. So 180 meters length of beam. Next, dead load due to beams is length, breadth into depth D into unit weight. So length is 180. Dimension of the beams, it is given as 250 into 400. So that is 0.25 into 0.4 into 20. So I get the answer 450 kilonewtons. Third point, for the columns. Total there are 16 columns. 1 2 3 4 4 into 4, 16 columns. Height of each column is 3 meters and its dimension is given as 450 by 450. So first I will be finding total height of the columns. 16 number of columns of 3 meter height. Total column length. Remember, we are calculating each floor. So these are the calculations floor wise. Is equal to 16 into 3, 48 meters. 48 meters is the length. B into D is 0.45 into 0.45. So dead load due to columns is equal to 48 into 0.45 into 0.45. So you get 243 kilonewtons. Next, fourth point, due to wall loads. Here assume walls only on outer beams. So we are assuming that walls are only on the outer beams. There are no walls on these beams. So total length of wall will be 22.5, 22.5, 22.5, 22.5. Height of the wall will be this much, 3 meters each. So length of walls is equal to 22.5 into 4. You will get 90 meters. Dead load due to walls is equal to length into thickness. Thickness is 0.12 into height is 3 meters. Unit weight is 20. So you get 648 kilonewtons. Fifth point, live load. Now live load is given as 3 kilonewtons per meter square. Now for calculation we are assuming 25% of the live load for the seismic load calculations. These are the code specifications. Assume 25% of 3 kilonewtons per meter square for seismic design. So load due to live load is equal to 25%. So 25 divided by 100 into 3, and this live load is acting over this whole surface. So 22.5 into 22.5. 22.5 into 22.5. So you get 380 kilonewtons. Now we'll continue with loads on each floor. Now let us look at the plan. For this plan, let us give the names. Let load on this floor be W1, W2, W3, W4. Now if you look at this floor, this W1 load includes dead load of slab, dead load of beams, dead load of columns, dead load of walls and live load. And same W1 is same for W1, W2 and W3. But if you look at top floor, W floor, here live load does not act because we are assuming that on the top floor no live load, and also there are no loads of wall or column. Now according to code specifications you have to calculate W4. For W1, W2, W3 it is dead load of slab, beams, column, wall and live load. So I'll start writing the equations. W1 is equal to W2 is equal to W3 is equal to, so 1898, that is slab, plus beams 450, plus columns 243, plus wall 648, plus live load 380. So I get total 3619 kilonewtons. This is the load W1, W2 and W3. Next, load on top floor W4. On W4, it includes full slab load 1898 slab load. Next are, what is next? Walls. So there are no walls, sorry, it includes beams. Beams are included. Next, we have to include, what is that? 243. And what is 243? Due to columns. So columns, what code says is 50% of the loads you have to include on the top floor. So 243 divided by 2 columns. Next, similarly for beams, sorry, for wall loads 648, again you have to include half of the wall loads. Next, live load is 0 because no live load is acting. What code says is, even for the top floor you have to add 50% of the column loads, 50% of the wall loads. So adding all this, you get 2793 kilonewtons. This is W4. Total seismic weight W is equal to W1 plus W2 plus W3 plus W4. This is equal to 3 into 3619 plus 2793. You get 13,650 kilonewtons. Next, step 2, base shear. Total base shear VB is equal to AH into W, and AH is equal to Z by 2 I by R SA by G. Next, Z, zone factor. So for zone factor nothing is given, so you can assume Z is equal to, one second, is that given? Now for response reduction factor, go to page 23, table 7. In the problem it is given as ordinary moment resting frame OMRF. So for OMRF, response reduction factor R is 3.0. For OMRF, R is equal to 3. Next, calculate period TA. So for this, go to page 24, clause 7.6.1. Page 24, it's here. 23, 24. Now, if you look at the problem, let us look at these two equations. Here, fundamental period T is equal to 0.00758 and T is equal to 0.085. This is for steel frame, this is for RC frame. So RC frame building means it is special moment resting frame. But here it is given as of a moment resting frame without brick infill panels, means without brick walls. But in our given problem, there are walls in the RC frame. So there is infill masonry wall. So for that, go to this case, the same page 7.6.2. The approximate fundamental natural period TA in seconds of all other buildings including moment resting buildings with brick infill panels, means with brick walls. TA is given by 0.009 divided by under root D, where D is base dimension of the building at plinth level in meters along the considered direction of the lateral force. So D is dimension of the building at plinth at foundation level. So TA is equal to clause 7.6.2 actually 7.6.2 TA for OMRF with infill walls. TA is equal to 0.09 H divided by under root D, where H height of the building is 12 meters, D dimension of the building at plinth level, it is 22.5 meters. So TA is equal to 0.09 into 12 divided by root 22.5. I get the value 0.2277. Using this, calculate spectral acceleration. Spectral acceleration coefficient, that is SA by G. So for this, refer to figure 2, page 16. Now let us go to the figure 2. Yes, here my fundamental period TA is 0.002. 0.002, it lies somewhere here. And for medium soil, for this graph, if interpolate, you'll get it here. From here, interpolate here, you get 2.5. So SA by G is 2.5. For TA is equal to 0.2277 and medium soil, SA by G is equal to 2.5. Next, calculate AH Z by 2, it is 0.16 by 2 into I by R. I is 1, R is 3, SA by G is 2.5. So you get 0.0667. Now base shear. Base shear VB is equal to AH into W, seismic weight. So AH 0.0667 into W, W is 13650. So VB, you get the answer 910 kilonewtons. Now we'll start with next step, step 3. Shear distribution along the height. First let me draw the diagram. So these are the 4 floors. Let these be forces Q1, Q2, Q3, Q4. Height 3, 3, 3, 3. Let this height be H1 is equal to 3. Here H2 from here to here, H2 will be 6, H3 will be 9, H4 will be 12. W1, W2, W3, W4. So W1 is 3619, 3619, 3619, 2793 kilonewtons. Now I will start with the tabular work. Before doing the calculations, I am going to find summation of Wj into Hj square. That will help me with calculations. So Wj at each floor, 3619 into W1 into H1 square, 3 square, plus W2 into H2 square, 3619 into 6 square, plus 3619 into 9 square, plus 2793 into 12 square. So solving this, I get 858186. Now I will complete this table. 4. So at 4th floor, load, seismic load is 2793. 3rd floor 3619, second 3619, and again 3619. Its floor level is 3, 6, 9, 12. Wi square here after calculations I get 42264, here 293139, 130284, 32571. So Wi square divided by summation of Wj Hj square, already I have calculated this, into Vb. I get story force at each floor level. So 426.5, 310.8, 138.14, 34.54. Summation. So top floor 426.5 as it is, 426.5 at this floor, this plus this 737.35, at this floor 1 2 3 all three together 875.5, at this floor all together, so I get 910 kilonewtons. Now let me draw the diagram to show the distribution. So here forces are acting Q1, Q2, Q3 and Q4. So Q4 is 426.5, 310.8, 138.1, 34.5. These are the lateral forces. Now lateral force distribution. If I had to draw the graph, its distribution would be something like this. Distribution. Here even you can show the forces. You can indicate these forces 426.5 like this. Now let me draw shear force distribution for each of the floors. So this is 426, 737, 875, 910 shear force distribution. This completes the diagram. Thank you.